Okay, this video is to go over the basics of how to run VBET. So the first step is to download the tool. If you've already downloaded the NHD Network Builder tool, VBET comes in that same toolbox. If you haven't, you can go to this Bitbucket repository with this link here and go to Downloads here on the side and click on fhcnetworktools.zip. And that will download a zip file that you can extract to whichever location you want with the toolbox in it. Then if we come into Arc, you can open the Arc toolbox, right click, add toolbox, and navigate to wherever you saved it. And then hit open. So then inside that toolbox there's going to be the valley bottom extraction tool. So to run the tool, two inputs are required. The first is a DEM. So we'll do an example of the middle fork of the John Day. This is the 10-meter DEM from the USGS NED dataset that's just been clipped to the watershed boundary. And then you also need a stream network. So this is our network. This is the NHD 24K network subsetted down to the perennial network for the middle fork of the John Day. So to run VBET, the first thing you're going to do is set your workspace. And so that's just a location where some temporary files are going to be stored during the process, and also a flow accumulation will be stored here if you don't already have one. So you choose your DEM, there, the stream network, and it's worth noting that the DEM and the stream network should both be projected in the same coordinate system. The tool won't run if they're not in a projected coordinate system. So we're using just the UTM coordinate system here. And then optionally you can provide a flow accumulation raster. So if there are portions of your network that contribute, or if the area of interest has areas upstream that contribute flow to it, then you need to run a flow accumulation beforehand to get accurate values. In the case of the middle fork here, there's nothing upstream of this watershed, so we don't need to worry about that. So you can choose to provide a flow accumulation to make the tool run faster, or you can leave it blank and it will do a flow accumulation on its own and store it in the workspace that you specified. I have already done this, so I have a flow accumulation. It saves it as a strain area square kilometer. And then you specify your output. Just name it this. So then there's a few settings here that we can adjust. So the first is this large buffer size. So what you want to do, we'll go here into Google Earth. The large buffer size, it applies to the widest parts of the valley of the area of interest. So this is the middle fork of the John Day here, and the widest parts of the valley are up here in this portion that's less confined. So if we just kind of zoom in on this area, and then we can use the measure tool, and I'll just measure from the river to the edge. That'll give us a good buffer width. So it's telling me about 470, 480 meters. So we'll go ahead and use that as our wide buffer size. And then it asks for a medium buffer size. So this is the portions of the network that are maybe a little narrower, partly confined areas. Which there's not a lot of these medium size. We'll just kind of zoom in here and get an idea of it. So here we're looking at over 100 meters for the tool. We can call it 150. The small buffer size is going to be like the more headwater confined reaches. We usually use something around 25. And then this minimum buffer size provides a minimum buffer in cases where it's either extremely confined or very steep or something like that. So 10 is just kind of a good minimum buffer size. You can go smaller if you want. And then this minimum aggregation distance. So this is a distance, and if the distance between polygons in the output is less than this distance, then they'll be aggregated into one polygon. So we'll do 150 meters. This minimum area is the smallest that a polygon can be to be kept in the output. So we'll say 30,000 square meters, and the minimum hole size is the smallest that a hole within a polygon can be to be kept in the output. So we'll also call that about 30,000. And then once you have everything filled out, just hit OK. And runtime depends a lot on whether or not you're providing a flow accumulation raster. If you're not, it can be a couple hours to run, and if you are, it's just a couple of minutes. Okay, so the tool ran, and this is the initial output for the valley bottom for the middle fork. So we can just kind of zoom in here and scroll around and see that it did a pretty good job with the settings that we gave it. If you think that something looks off, you can go ahead and go back and adjust some of the settings and rerun it. And since you'll already have a flow accumulation saved, it won't take as long for subsequent runs. And then after that is when you're going to want to do the manual editing to get the degree of accuracy that you want.